Straight lines are a concept you will have come across at GCSE, and surprise, surprise, they come up again at A-level. So whether you're about to be going through an A-level geometry or graph-based question, or if you're just feeling like a refresher, here are some of the concepts involved with straight lines, be they new ones or reminders. To start off with, the general formula for a straight line is y equals mx plus c, where y and x are standing in for your x and y coordinates of any point that lies on that line. M is then your gradient, that is to say how steep or shallow the line is, and then here your c is your y-intercept, that is to say when x is 0, where does the line cut the y-axis? The x-intercept, while not part of the general equation, would then be when y is 0. If we weren't having the equation of the line given to us, what we could do is we could work out the gradient as that being between 2 points on the line. We could be just told that these are 2 coordinates on the line, or if you do have a graph, you can pick 2 points that you can read off easily. What you'll then do is the two y values minus from each other, so the difference in y, and divide that by the two x values minus from each other, the difference in x. Okay? And because it's a straight line, this gradient is going to be constant throughout. If you have a curve where your gradient is changing, that will come under the later topic of differentiation. Other things we can do about these points that may be on lines, we can work out the length between those points, or the distance. This is essentially Pythagoras, where split the difference between the two coordinates into an x component and a y component. In other words, how far are they apart horizontally and how far apart vertically. This would give you a right-angled triangle. So we'll have the difference in the x values squared plus the difference in the y values squared. And that, yep, will give you the distance between them, would give you the hypotenuse, the long side of that right-angled triangle. Alternatively, we could look for the midpoint of these 2 points, so the coordinates of what is exactly halfway between these two. This you would find by now adding the x coordinates together and divide it by 2, and add the y coordinates together and divide by 2. So these are some principles that we can do using coordinates. For the lines as a whole, we can then give them further descriptions, further properties. We can either describe them as being parallel or perpendicular. Parallel is to say that the two lines would have the same gradient. So they will never meet. These two or more lines going in the same direction constantly. So they have the same gradient, but they'll have different y-intercepts. Because if they had the same gradient and the same y-intercepts, then they would just be the exact same line. They'd be on top of each other. Meanwhile, to say lines are perpendicular is to say that their two gradients times together would equal -1. Or just in a, how would you visualize that sense? Lines meet at a right angle. So they cross one another rather than being in the same line. And that is at 90 degrees. So if you knew the gradient of one line, you could work out the gradient of the other line by saying, okay, rearranging this, it would be -1 divided by whichever gradient you knew. Or, if you want to check if lines are perpendicular, if you times the gradients together, do they equal that -1? Okay. So these are your main principles that you're going to be using in questions to do with straight lines. If we just wanted to have a go in an example, we could say that there's a point P, which has coordinates 5, 8, and a point Q, which has coordinates 10, 6. So find the equations of the line PQ and its perpendicular bisector. So if we're looking for the equation of the line PQ, we say, well, what line would go between these 2 points? And perpendicular bisector. Perpendicular, well, just from above, we're saying it's going to cross the line PQ at 90 degrees. But also bisector means it's cutting it in half. So the coordinate it's going to go through is your midpoint. With this in mind then, let's go about seeing how we construct a y equals mx plus c equation. To start off with, for finding PQ, we'll work out the gradient, and for this we'll use our difference in y over difference in x. So let's say we've got our 6 minus 8 over 10 minus 5. It doesn't matter which coordinate P or Q you do first, so long as you're consistent. So because we did 6 first on the top, 10 comes first on the bottom. But if we'd done 8 first on the top, then 5 would have come first on the bottom. This then gives us a gradient of minus 2 over 5. What we can do here is now start plugging in values to this y equals mx plus c. We know y and x values from the coordinates we know it goes through, and we know the gradient now. All we need is the c. If we pick either of these pairs of coordinates, I'll pick p. So for y, we can say that that'll be 8. Now that's going to equal, our m is that minus 2 over 5, your x is the 5, and then we have plus c. Well, minus 2 over 5 times 5, the divided by 5 and times by 5 cancel, leaving us with just minus 2. So if 8 equals minus 2 plus c, to get c on its own, you would add the 2 over, giving you c as 10. Therefore, we can say the general equation of the line is y equals minus 2 over 5x plus 10. Remember, in the final equation, your x and your y are remaining generic to plug in any of the actual coordinate values. If you then needed to check a point was on this line, you could plug in the x coordinate and see if it gave you out the appropriate y. As for the perpendicular bisector, because we have the gradient of the line PQ, we can get the perpendicular gradient next. But first, I'm actually going to get the midpoint of PQ because it's a bisector. So, if we were to add the x coordinates together, so 5 add 10, divide them by 2, do the same with the y's, so 8 plus 6 over 2, this would give us a midpoint of 15 over 2 and 7. You could write this as a decimal if you want, it's just the fact I've been using fractions so far, and you might as well be consistent. Now, to plug this into the equation as we did before, because again it's a straight line, because we know it's still going through the midpoint, we'll say our y coordinate is 7. Now when this equals, this m, if minus 2 over 5 times something equals minus 1, bring this over the other side, so minus 1 divided by minus 2 over 5. This gets you 5 over 2. Basically, the sign in front changes. If it was a plus, it would now be a minus. Since it's originally a minus, it now becomes a plus. And in the event of a fraction, it basically just flips the fraction on its head. Again, you can put this in the calculator to be sure anyway. Then this gradient is times by your x coordinate of 15 over 2, and you have a plus c. So here what we're going to have is c is going to be 7 minus this together. So 5 times 15 is going to be 75, and 2 times 2 is going to be 4. So from that, we get that c is minus 47 over 4. So we could say that y equals 5 over 2x minus 47 over 4. Now, if we wanted in both of these cases, we could actually now make these all integers. Sometimes a question specifies it, so in the form of, I know they're all on the same side and they're all integers, you may have to move things around the equal sign, times things up. Moving things around the equal sign is just either plussing or minusing as is appropriate, the opposite of the sign that it currently has. As for timesing up, if I just do the example with the perpendicular bisector, because it's a divide by 2 here, and a divide by 4 here. If we times by the bigger of those numbers, the 4, what you'll end up with is 4y equals, now timesing by 2 would get us back to 5. So now timesing by 2 again, so overall of times by 4, that now gets you 10x, and then this, when you times by 4, just becomes your minus 47. So if you want to bring that on the other side, you could do. For the first example, you would have timesed up by 5 to get 5y equals minus 2x plus 50. if we're okay with this, let's see how you can get along with an example of your own. So on the right, we are told that the line L1 has the equation 2y minus 3x minus k equals 0. Given that the point A of 1, 4 lies on L1, find k and the gradient of L1. Once you've done that, the line L2 passes through A and is perpendicular to L1. Find the equation of L2, then find point B where it crosses the x-axis, and then finally the exact length of AB. So consider the different concepts that we have talked about here, the different characteristics of a straight line we can work out based on its coordinates and the description given. Consider that if you were looking for either the gradient or the y-intercept, it does have to be in this y equals mx plus c form, where the y is on its own as a single y. Pause the video, have a go for yourself, and then press play again when you're ready to compare. So, given that we know that point A is on this line, we know if we were to plug in x is 1 and y is 4, that the equation should equal 0. So if we do just that, we say, okay, so 2 times 4 minus 3 times 1 minus k is equal to 0. Well, 2 times 4 is 8, and 3 times 1 is 3. So we have 8 minus 3 minus k equals 0. Therefore, k is going to equal 5. Then, if we want to work out what the gradient is, we need to get it into a y equals mx plus c form, get the y on its own. Right now, it's having this 3x and this k minus from it, so we want to move those away. The only place they can go is over the equal sign, but when they go over the equal sign, their personal sign changes. So we end up with 2y equals 3x, and now because we know k is 5, plus 5. So from that, if we just divide by the 2, y equals 3 over 2x plus 5 over 2. Remembering that if you divide anything by any given number, every term gets times by that number. So by dividing by 2, everything gets divided by 2. With that in mind, therefore, the gradient of line 1 is going to be that 3 over 2. The next part was then line L2 passes through A and is perpendicular. So if we're going to find the equation of L2, we need, an x and y coordinates and the gradient. Well, we know the x and y coordinates because it passes through A. We know x is 1 and y is 4. All we need is the gradient. So we can say that your 3 over 2 times whatever the gradient of line 2 is going to be minus 1. So dividing that across, you get that your second gradient is minus 2/3. Plugging this into your y equals mx plus c, we can say that 4 equals minus 2/3 1 plus c. So minus 2/3 times 1 is just minus 2/3. So c will therefore be this 4, add the 2/3, leaving you as c being 14 over 3. Plugging this all into a single equation, you would have y equals minus 2/3 x plus 14 over 3. If the question had specified that it wants it all as integers, maybe it wants it in the form like we had for L1 up here, where everything is on the same side as well. What we could say is we'd times up by 3, so we'd have 3y equals minus 2x plus 14, and then bringing everything over, 3y plus 2x minus 14 equals 0. As for where point B is, if point B is where it crosses the x-axis, the line will cross the x-axis when y is 0. So if we say we've got 3 lots of 0 plus 2 lots of x minus 14 equals 0, you end up essentially just with 2x minus 14 equals 0, because anything from 0 disappears. If 2x minus 14 equals 0, add the 14 over, 2x equals 14, so x equals 7. Thus B has coordinates of 7, 0. And finally, about the length, we're now going to use this formula from up here. So I have the square root of the difference in the x coordinates of a and b. So let's say we'll go 7 minus 1 squared, and then the difference in the y squared. So 0 minus 4 squared. Of course, you can just put this in your calculator. We're essentially just getting 36 add 16 all under a square root, which in other words will just be the root of 52. The question specifies it wants it in exact form. This means leave it as a surd, not a decimal. So yeah, that's where you would finish your question. If you wanted, you could try to simplify that if possible. If you want to know how to simplify a square root like this, I'd suggest going over the surds video. If we're okay with that, let's just turn our attention then to one more question, this one from paper. So we're given this diagram here, where you've got these 4 points A, B, C, D, and we're told that A has coordinates 1, 7, B has coordinates 27, C has coordinates P, Q, we don't know what they are, and we're told that they form the corners of a triangle, and then D, 8, 2, is the midpoint of AC. So first of all, we're going to find the values of PQ, or P and Q. So what we're going to do for this is we're going to use the fact that D is the midpoint to work this out here. If we're going to say essentially that 1 plus this second x value over 2 is the same as the x coordinate of the midpoint, 8, if you were to times the 2 up, you'd get 1 plus the x value equals 16, therefore the x value is going to equal 15, which makes sense because the other way of doing it would be to say you've gone across 7 here to get from 1 to 8, so you'd go across 7 again, and 8 add 7 is 15. To do the same for the y, we'll say that your 7 add your y2 over 2 equals that 2 there, so 7 add y2 equals 4, so y2 is therefore going to equal minus 3. You want to double check that. To get from 7 to 2, you'd go down 5. If you go down 5 again from 2, yep, minus 3. So this is your P, P being 15, and this is your Q, Q being that minus 3. Now then, line L, which passes through D and is perpendicular to AC, intersects AB at E. So there'll be some kind of straight line coming out here at a right angle, and that cuts here at whatever this point is. Find the equation for L in the form of ax plus by plus c equals 0, where a, b, and c are integers. So that's just what I was saying before about how they can specify the form they want you to rearrange your equation of a line into. Well, in order to get this y equals mx plus c first, we need x and y coordinates. We have that because we know it goes through D. And then we need the gradient. This we currently don't have. If we wanted then, we can do our difference in y over difference in x. This can be done either between a and d, or between a and c, or d and c. In questions where you have this choice, I would always suggest just using the numbers that the question has given you, just in case you made an error in the previous part. So I'll be using the a and the d here. So what we'll say is we'll have 2 minus 7 over 8 minus 1. That's going to give us minus 5 over 7 as our gradient. Well, the gradient of AD. Because this line here is now perpendicular to it, we'll be saying that that's going to say minus 5 over 7 times m2 equals minus 1. So m2, if you divide this across, is going to end up at 7 over 5. Plugging this into a y equals mx plus c, you know your y equals 2, so 2 equals 7 over 5, and your x is 8 plus c. If you were to times these together, you would end up with 2 equals 56 over 5 plus c. Therefore, c is going to be 2 minus the 56 over 5, with minus 46 over 5 being your c. So, y equals 7 over 5x minus 46 over 5. Because we want these to be all integers, we'll now times up by this, well, the common denominator of 5. So 5y equals 7x minus 46. And bringing everything onto this side here, you'll have minus 7x plus 5y plus 46 equals 0. It doesn't matter that that's a negative x here. A can just be the whole of your minus 7. Alternatively, you could have brought the y over to have 7x minus 5y minus 46. That's just as valid. And again, it doesn't matter that they'd be negatives, because the b and the c can just be the negative numbers in and of themselves. And now then, find the exact coordinate of E. So this is going to be where our line L intersects with this line here. Well, in this case, we know that because we can see here A and B, that's a flat line. The y coordinate isn't changing, it's 7 in each case, so it's horizontal. That the y coordinate of E is also going to be 7. So if we just substitute that in, so we have our minus 7x plus 5 lots of 7 plus 46 equals 0. You have minus 7x, then 7 times 5 is 35. 35 add on to 46 is going to give you plus 81. So A equals 0, add the 7x over, 81 equals 7x. So x is going to give 81 over 7. The exact, oh yeah, and that is just the x coordinate. You don't have to worry about the y, because as I say, we know that that would be 7. Well, this is the end of the question here. There is just one other thing I want to mention. Because here this is talking about where we'll find the exact coordinate of E, where this line had intersected. Here it was rather straightforward because we know the y coordinate was going to be 7 because it's a horizontal line. If it hadn't been that easy though, what you would have had to have done is set the two equations of those lines equal to each other. So here you'd find out the y equals mx plus c of a to b. And you say, okay, if you can make them both y equals, you can then set them equal to each other, solve for x, and then plug back in for whatever the y coordinate was. Alternatively, in some other cases, when you have curves intersect with straight lines, you may have to substitute one equation into the other. So again, if you can get a straight line equals y, you'd replace the y coordinate in the curves equation with that expression, rearrange and solve, you may get a quadratic. In those cases, if a question isn't necessarily telling you or to work out the exact coordinates of where it crosses, but rather just how many times these lines intersect, we can use a graphical method. So for instance, here we can see that this line here, L, and this line AB, they're only going to cross once because they're two straight lines. They'll keep on going in different directions after that point. But in a curve, you never know. Does it meet once? Does it meet twice? Does it not meet at all? It depends on what the turning point of the curve is and where the line is going. If we just want how many cuts, therefore, how many intersections, and we don't have a graph, there is just this one other thing we can use, and that is what I want to mention here. This is called the discriminant. Now, this is only going to work if you have a quadratic graph, so a curve like this or like this, and this is presumably going to be intersecting with a straight line going through it. Maybe there's going to be something like that. Okay? You'll need to have set these equations equal to each other, right? You will have needed to substitute the straight line equation into the curve equation as I've been describing. So make the line equal to y and replace the y in the curve equation with this x equation and bring everything onto the same side. You should then get some quadratic expression of ax squared plus bx plus c equals 0, the general formula for a quadratic. The discriminant is then, if we were to take these a, b, and c values, so the coefficient of the x squared, the coefficient of the x, and then just the c on its own, if we were to do b squared minus 4ac, and this phrase you may recognize from the quadratic formula, which we use to find solutions to quadratics. If you plug the a, b, and c into here, if this discriminant was greater than 0, then there are two solutions. that these lines will intersect twice. If it equaled 0, then there would be one solution, and if it was less than 0, there are no solutions, or no real solutions, meaning that lines never touch. This doesn't tell you what coordinates they are. You'd still need to solve as you would do in general, just by solving the equations. But it does tell you how many you should expect to find.